2, 1. Welcome, everybody. Today is the 29th of July, 2025. This is Dallas Personal Robotics Group Robot Builders Night Virtual. We'll do the usual thing tonight and just we have a short queue of folk with things to show or questions to ask, and then open mic. And this being the summer months, a little lighter group tonight, but that's all right. So our queue at the moment looks like Mike, and then Ray, and then John, then maybe Harold will lead us off into open mic. And with that, any club business or anything before we jump in? We had a session on Friday with 6 or 8 people. Saturday that was at the Makerspace, and that was pretty nice, just random ad hoc chit chat. But tonight we'll do it virtual. So all right, so Mike, you've got something to demo for your next call.
Yes, I've been trying to get my 1/6 scale model outdoor car platform to drive, and I'm still trying to figure out the meters per second. Like I'm trying to get it controlled with meters per second. So I give it a command at meters per second, and I really wanted to move 1 meter in 1 second. If I'm, or over 10 seconds, if it's at 0.1 meters per second. So I'm just trying to get it to just be open loop with time right now. And I was trying to just hand tune it. It's like, oh, I put a measuring tape on the floor and said, okay, start and go from here to here for 1 meter, and sort of tuning, like hacking on the variables and go, oh, I made it, but it would never converge. And so it's like, oh, it's probably that darn. It's not voltage regulated in the ESC controller in the car, and so I decided, okay, I'm going to figure out the voltage relationship to the meters per second setting, and so I put a script together that ran on my bench, not on the floor, and I just said, okay, run it at 0.1 meters per second for 10 seconds, and then 0.2 for our 5 seconds, up to 1 second at 1 meter per second. And I did that over and over and over and over and over again. I collected the time and the battery and what I set it to run at and the encoder value from the shaft encoder. And the good thing is I don't think my shaft encoder is slipping, so that's good. But I'll show you the data. So the data was collected on my Raspberry Pi 5 with an SSD and running a desktop. And so I pulled up Open Office spreadsheet, and so I have it all on my robot. So let me bring up that screen, the VNC screen. Okay, so so this is the data. Can everyone see it?
Yeah, and can you confirm again? So this is the voltage across the motor.
Okay, that's a different one.
What is this?
Okay, this plot here is voltage versus time. And so the battery starts at 12.5 volts.
Okay. And
then over a couple hours, it's sort of at around 11.3 volts or whatever. It goes sort of flat, and then it starts tapering off, and then it goes off a cliff. And the cliff is about 11 volts. So, but I said, okay, I'm going to stop my test at 10.5. Yeah, so I don't, damage my battery. And
what chemistry are you using?
LiPo, lithium phosphate.
No, LiPo is lithium polymer.
Oh, polymer. Oh, polymer. Okay, it's LiPo. Yeah. Thank you. It's just LiPo. So, yeah. And so basically, I'm going to set on my robot. I'm going to say stop running or make a big something big or alarm or something when I hit 11 volts because you're in danger. Because I noticed that on my transmitter, when I turn my transmitter in, it has a voltage meter on it too. It gets telemetry over the RF, and it was beeping at me. It says, "I don't like this voltage." I think that's why, because it just goes off the cliff right there.
Hey, do you know? Can you measure individual cells on the pack, or do you only measure the top voltage?
I can measure individual cells. Yeah.
Somebody's asking $10 a piece for a coaster. I don't know, man. I don't know. You know, if they're like custom, we love you
Okay,
coasters, and this guy grandma's.
So yeah, so
I didn't
so the
plot
reason
out.
I ask is that right, the cells might be imbalanced if one is somehow aged faster than the others.
Let me go look at my charger. I'm charging it up right now.
Well, 3
I've got
lithium ions charged,
Yeah.
fully charged would be like 4.2 volts each. So,
But you don't
No.
want any individual cell to go below 3, basically.
Yeah, I've been doing RC rock crawling for years, and I can tell you from experience that when you get down below 11 volts, the performance just goes to crap.
Yeah.
So I never run below 11 volts when I'm doing that kind of stuff. And I mean, his thing is basically an RC rock crawler.
But you just worry about the top line voltage, Sean?
Yeah, no, I mean the batteries get balanced
Yes.
every time you charge them. That's
Yeah,
really not an issue.
Yeah, my battery pack is quote smart, and it has battery management logic in it. And last time I checked, the cells were balanced. For some reason, I can't figure out how to see it on my charger right now.
Yeah,
So
I mean all reasonable LiPo chargers auto balance as
Well,
they do that.
I get that part, but what I don't have experience in is whether all LiPo cells age at the same rate, because it just seems to me possible. It happened all the time with NiCad, right? But
But that's a whole different chemistry. I
Whole
mean,
different
LiPo's like, I've run probably 50 or more cycles through my 3S LiPos that I used with my RC rock crawler, and I've never had any kind of an issue. I mean, if you're using absolute crap batteries from AliExpress, you might have that problem. But if you're using name brand LiPos, which I'm assuming Mike is because he's running them in a really expensive crawler, it's just not an issue.
Like right now, my 3 cells, one is at 3.97. Oh, they're all 3 at 3.97, and they're halfway charged up. So yeah,
got lots of energy in them. Okay, well, never mind the angle I was going at. You've convinced me, John. As long as you're getting good batteries.
Yeah, I mean,
I checked my charger. I checked my charger, and it gives me the voltage for each cell. So
yeah, I have a little battery checker that I bought a long time ago that you can just plug the balance plug in, and it tells you the overall voltage as well as for each cell. The thing, I mean, the nominal charge on a LiPo is 3.7 volts, but what I've found is that 3.7 volts times 3, because they're 3-cell batteries, is about just over 11 volts, and that's about where the battery loses its usefulness. I mean, you can still run it for a long time after that, but it doesn't have anywhere near the kind of power that it has in the top half, from about 11.1 up to 12.6, which is where they're fully charged.
You'll also damage its lifetime if you keep running it off that cliff.
Yeah.
Right. Yeah, because this whole plot is over 2.7 hours, so a little more than 2.5. So it ran really good, and then right around 2 hours and say 2.5 hours, then it went off the cliff.
Yeah,
So-
yeah. I would just advise you don't run under
Yeah.
11.1 volts, and then you
Right.
won't have a problem.
Yeah. So I need to put a stop in my code.
Yeah.
Says, hey, stop running or put a big signal out of some sort.
Yeah.
And-
So
and then
what I
stop.
did with mine, I have you can buy these little the little digital voltmeters. They're basically just a 3 or 4 LED thing with digits with a couple of wires, and you can plug it into a 12-volt source, and anything up to 13 or 14 volts or whatever, and it will tell you what the voltage is. And so I have one of those plugged. I plug my balance plug into that when I plug the car in, so that I can see what the battery voltage is, when I'm walking behind the robot.
Mhm. Yeah, because I'm reading this out of the electronic speed controller.
Yeah.
The voltage going to the speed controller. So my software can read the parameters, the telemetry, the data out of the speed controller. So it's basically, so I'm reading the voltage out of it, and that's what I get. So
I gotta say that. So excuse me. That's kind of a weird looking curve to me for a LiPo. Usually in the middle, it's flat for a really long time.
it's sort of flat for half the time, I guess.
Is your horizontal scale linear?
Should
What-
be.
What is the horizontal scale?
Oh, that's milliseconds, read as a timestamp out of the microprocessor.
And this,
This is
Oh.
milliseconds.
Oh, so
Yeah.
this is just charting the voltage as it drops.
Right, as I use it. And, yeah,
Just
'cause I'm
starts
running-
there.
Okay. Then
Yeah.
that is. I mean, it's a linear line. The voltage drop is very linear on until you get down to the nominal voltage on a LiPo. That's the left side of that graph, if you plot it, is almost linear.
Yeah, it looks like it. Yeah. Mhm. And then it
So
sort of
that's
flattens out.
exactly what I would expect to see, because the voltage is going to drop, as you're going. It doesn't stay at 12.5 volts
Right.
for any
Right.
length of time. It drops at a consistent rate. It's just the difference is the amount of power that the cells can produce at a given voltage stays
Mhm.
fairly flat until you get down below 11 volts.
So is this under load the whole time?
Oh yeah, it's running a speed test on the bench, just spinning the wheels. So it's
Without
it's
any
spinning the wheels for
resistance.
2.5 hours. Yeah.
But in air,
Right in there. Right.
so it's almost no load motor wise
Right.
from your motor's perspective. Yeah.
Yeah, it's stopping and going, but yeah. A lot of the load is just all the electronics. Like I have a modem on or a router on it and a Raspberry Pi with an SSD. Those draw lots of power, I guess I should have read the current out of the. I should do that. Read the current out of the speed controller. But yeah, that'd be interesting.
Well, just to make sure the current is roughly constant over this time period.
Yeah. So this is it. This is I just did the voltage over time going, what's going on here? I shouldn't set it at 10.5. I need to set it at 11 or 11.1 or something. Yeah. So maybe 11.1 is like it'd be in warning at 11.2, and then 11.1 would be like warning.
Right.
Yeah.
Well, I
red.
thought you put encoders on it. You don't
Huh?
really need to tune your speed for your current battery level if you
Yeah.
have a PID loop and you've got encoders
Right.
on it.
But I want
Right,
to understand what I'm working with. Yeah.
Right. But the other thing you have to realize is that that's a brushless motor, right?
Right. Mhm.
So it's running FOC, field oriented control, and so it's going to take the signal from the radio, and it's going to try and run the motor at that speed regardless of the load and regardless of the battery level. So that should be a very
Yeah.
constant speed.
I was hoping. So that's what this next chart is.
Yeah.
So this is the battery voltage versus my encoder value. I didn't close the loop, it's open loop. I just ran it for time.
Well, that's
So,
pretty darn linear.
well, but it doesn't look like that voltage curve, but yeah.
Yeah.
So it looks different than the voltage curve, but I guess part of the voltage versus time. And if I plotted this for time, let me try that. Where's my,
How do you get VBAT down to like 1 volt?
where?
I don't know, the right side of the.
For some reason, when I do a pivot plot, it doesn't put my battery voltage here. It just puts in the.
Oh,
the
it
numbers.
puts the. Okay.
Yeah,
Gotcha.
I was looking on it going, I want the battery voltage, but
Yeah.
I couldn't find a way to do it. There probably is, but
Okay, so basically it is slowing down more or less linearly over time.
Yeah. So if I go in here and I change it to, so instead of V battery, if I change it on time, oh, wait a second.
Or column A. Okay. Feedback.
Now I can I can see the curve that I saw, the battery curve. Yeah. But yeah, this is just a linear line fitted. But if you sort of look in this data here, you can see it sort of going down and then leveling off and then going over the cliff. So, okay, it's just the delta, like when I run a test, it's like run for 1 second at 1 meter per second and give me the delta encoder value. And then also at 0.1 seconds, I run it 0.1 meters per second, I run it for 10 seconds and I get basically the same encoder value. But yeah, so let me go back to this one here. And this is like the average stuff, but it's the average of delta encoder. So if I go to properties and go back to my battery voltage. Yeah, so that's a pretty linear line. So I was going, oh, well, I can sort of tweak my input to my ESC from what I wanted to do using a formula for this line, and I had it spit out the formula for that line. So I can sort of pre-adjust the pre-compensate battery voltage to try to get it more linear, and then the PID loop doesn't have to work as hard.
I think it's easier to just let the PID loop do its thing.
Well, yeah, but basically it's like try to keep it a little happier, but yeah. So if I go in here and but one thing I noticed is it's pretty noisy. Like if I do the minimum, yeah, so the average error and the minimum's there, and if I add in the maximum,
Wide
so
variance.
yeah, so you can see it's noisy. Like I'm not sure what the noise is, but I want the speed controller, I mean the PID loop to try to work on this noise somehow, and so I can keep it a little happier, I think, because it'll be going at different speeds all the time based on the navigation software. So hopefully I can keep the PID loop more stable by pre-distorting it. Because basically I know it's going to do it on voltage, but this other stuff is sort of random noises of some sort. I'm not sure what it is. It might be my time isn't precise, but it should be more precise than that I'm starting and stopping the engine. I should be starting and stopping it with a couple millisecond accuracy. So I don't know what's going on.
Do you filter the encoder delta values from across a few sample periods, or do you only use them raw?
When I start the test, I measure the encoder value, and then when my 10 seconds is up, then I wait a little while and measure my encoder value and then take the delta. So these values here, the delta encoder is the difference between the encoder value when I started my 1 meter run and then after my 1 meter run was finished.
So you've got a lot of samples averaged together for each data point.
Yeah. And yeah, so it's even noisier than this inside, and you know.
So you're basically starting and stopping all the time while you're running this test.
Right. I start it and then I run for a second or 10 seconds. Then I stop it for 2 seconds, let it settle down. Then I start. Then I change the linear velocity and the time, and then do another chunk.
Right. So the first encoders when the value is when the wheels are not moving at all.
Right.
And then you start. So you're basically taking the encoder value, including the acceleration up to that speed, from a dead stop.
Yeah.
As opposed to measuring it during a steady state speed. Right? Like let it get up to speed, then count the encoder, wait 10 seconds, count the encoder, and only then let it go back down again.
Right. Yeah, because
you're getting acceleration and deceleration.
And those
in
will
that,
vary
and that's-
dramatically, probably.
Yeah, that's going to mess with your numbers a lot.
That may be a huge factor of your variance.
Yeah, so I'm just trying to understand what I'm doing, and then I want to know I don't have good measurements of the shaft diameter and the wheel diameter and stuff like that, and the ratio of the differential. So I'm just trying to come up what is the encoder delta encoder to drive 1 meter. So I guess I could just run the test for a second, and then I could read the encoder value, run it for another second, and then read the encoder value, and then stop the test.
Yeah, that's the way I would do it if I was doing it.
Yeah.
You want if you're trying to figure out how far the thing goes in 1 meter, you need the motors running at a constant speed for that entire time. Because if it's accelerating and then decelerating, that gets factored into your time base and changes the, you're not going to get accurate values.
So I'm still working on just trying to understand what I'm trying to control. So I'm going to stop sharing. So this is like, what is this thing? I didn't design it. I don't really have perfect information on it. What is it? So, yeah, I'm still trying to understand what is this thing. So, all right. Well, that's what I can share, and I have another meeting at 8, which is now. So,
Well, thanks. That sounds like fun.
okay.
Good luck on calibration.
All right. Bye.
Good night. All right. That takes us to Ray, and then John, and then Harold and open mic. Ray, what you got? Muted. Got a lot of silence.
There we go.
Ah.
Still working on the gate opener. This is basically it's like cable covers is what they call them. This rectangular tube here. And I was gonna try to 3D print something like that, but it would take forever, and I could just go to Walmart's and buy this, and it came in the right length and all that stuff. So anyway, this has got a 3D printed like an adapter on the end. This is the pin that, goes through the end of the sleeve. And if I pull this off, let me pull the thing out. There is a little magnet in a little 3D printed block. So it senses, I put 2 Hall effect sensors on this that I just got in. So I haven't actually put them on a circuit board and made a little molded carrier for it to cover it. But that's what senses, you know, how far out to go and how far in to go. And then I have another one that was actually a Mighty Mule. Oh, and I'm on the Casler rule of seconds. You know, this is the, well, I'm printing the second one out now, but this was supposed to go over this and over the end of the rod here and hold the cable cover in place. I was just going to print a couple of those. Anyway, I had 2 sizes. This one was a little too small. The other one is a little bit too big. So
you're saying that the Castle rule of seconds based on the Ackley rule of thirds.
Of thirds, yeah. I'm not up to the Ackley rule of thirds yet. So and hopefully I won't be. But here's the other one. It's quite a bit bigger. Anyway, using the same scheme on it with the magnet and the Hall effect sensors, and it seems to work pretty good. This actually had a switch. Oops. A switch and a disc with a bunch of slits in it, and I didn't realize it, but I thought I could reuse the switch. The little opto interrupter got fried when it got hit by lightning, or something got hit by lightning, and just fried the internals of the thing. But I'm pretty certain that switch is bad because it was supposed to be used to, when the rod goes all the way in, as like a mechanical stop, because there's a limit to how far you can screw the rod in, and there's also a limit to how far out you can screw the rod. So, or how, have the rod be pushed or pulled. And anyway, so it would start to go back in and kind of randomly fail at different distances. And the more I kind of shook it around, the quicker it would fail. So it's like, okay, well, switch was bad. So that's why I decided to go with the magnets on the outside. So, and I think they were using an actual H bridge to drive the motor, because it did run at different speeds. So it would, like, you would give it a pulse count for the, how far out it was supposed to go. And it would slow down as it approached that. So I was just using, it's kind of like a bang bang controller, set of relays that either applied, 12 volts, one polarity, or 12 volts and the other polarity on the motor leads. And that's okay to do, but you have to absorb the inductive kick of the motor. When you break the connection from the 12 volts, it will try to, it'll produce a big spike. So you have to provide a path from the positive motor lead to the battery, basically, so that spike has, somewhere to be absorbed. And once I did that, everything was reliable. It would open and, close to the right positions, and very repeatable. I had little pencil marks on the thing, so I could watch it go out, watch it go back in. So, so all that looks pretty good. So I hope to have gate openers working, which will be really nice, because, when we leave here, it's like you have to go through 2 gates to get out of the property. It's a pain in the butt. Chiggers are in full bloom this year. So anyway, got some other parts. This was a motor driver. They're pretty cheap. They say they'll do 60 amps. I'll be happy if it does 30 or 20. That's about all I needed to do. Anyway, it's a dual motor driver, and it's got a pretty big heat sink on it. I didn't see anybody that, was, sticking a fan on this thing to cool it off.
12 volt.
I was kind of curious about it. Pretty cheap.
How many volts, Ray?
I think this one will do up to 30 volts. So it could, you could run on two 12-volt batteries, 24 volts. So, which that's probably what I would be doing. And I also got, and these things are clunkers, but they're pretty cheap. Two of these. It's just a big DC motor with a gear reduction on it, about almost 10 to 1, not quite 10 to 1, but and a 9-tooth sprocket on it. And you can get them in different voltages, different power levels. This one is a 24 volt, 350 watt. You can go, down to, I think, 12 volt, 250 watt, and I think up to 500 watt and maybe 36 volts. But it seems like this is one of the more common ones. And there's like this introductory price, you can only buy one. So I had to buy one from one manufacturer and one from another manufacturer, and to get the, the rock bottom price. So, but shipping was a lot less, than what would be desired. The box was like shredded. I mean, I've never seen a box that shredded before. And there's a few, like small marks on the casting, but it's an aluminum casting, and it doesn't seem to have cracked it or any of that kind of stuff. So anyway, so I think, yeah. Just to give you the level of the shipping, this was the box that the thing came in. It is like, it has been taped over and over and over again. And I was surprised that the thing didn't have a bent shaft when it came out of the box. But anyway, I had been playing around with three-phase.
That's what happens when you don't pay full price.
Yeah, free shipping
When
from
you
the
don't pay full
United
price,
States.
that's what they ship you.
Yeah. So, but yep. Anyway, there's the little mini Fock drivers. And there is another one. I don't have a pair of scissors with me. Darn it. Let's see if I can rip it open. Whoop. Oh, here's a knife. Oops. Come on. Whoop, 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 whoop. We've adopted a dog that's been abused in the neighbor here. This is she's a bloodhound. Okay, Ray, come on. You gotta go. Yeah, let's go. Come on. Scoot, scoot. Anyway, yeah, that poor dog, it's like 75 pounds underweight. It had both of its eyes were so infected it couldn't see. I guess that's what you get out in the country. People just don't take care of, well, some people don't take care of their animals. Anyway, so these were two of the older ST three-phase brushless motor drivers. Boop, boop. Or you could do the simple Fock, which is, I want to say it's based on the 8813 or something. John might know.
I have one here. I just gotta look at it.
Yeah, I forgot what the part number is. I thought it was DRV88 something.
No, that's a brush driver that Pulalu amongst other cells. I'll have to look it up because I can't see the side of the chip on my robot that has them installed.
Anyway, if I can get the part number off this one is a common driver. Blech. And of course it's unreadable.
Oh, no, you're right. It's a DRV8313.
8313. Okay.
Huh.
Okay, so these are it's an ST part, the L6234D. And so this little board has, it's got a 328p processor on it. And this, I think, was done by someone in Germany, I think. And so that's a 2-channel board that they have a little IMU with it connected to it, reasonably priced. And those drivers, I think, are pretty good drivers. I've seen several boards with discrete FETs in place of these larger brushless controllers. And yeah, FETs, you get much less of a voltage drop across the part. But they seem to have issues with, I don't know, with certain encoders. The ones that, it's got a magnet, and it's kind of a weird polarization on the magnet. Instead of the poles being on the larger surfaces, it's on the edges of the disc. And these sensors can actually sense it, but it seems like if they screw up, you smoke a board pretty easy. And so that's why I liked either the driver that John mentioned or boards with this driver, because they seem pretty solid. They don't seem to have that. And I don't know if it's what it is exactly, but if you either increase the voltage too fast or the speed too quickly, that's when they tend to fry. So anyway, so I wanted to get that board and play around with it. It was cheap. I think the board actually cost $2 and shipping costs like $4 or something. So for $6, I get to experiment with what seems to be a pretty good product, pretty stable, but different than kind of all the other products that are based on discrete FETs for 3-phase brushless. So, and this other one, I'm not certain what it'll do, but I didn't receive any feedback online for it. And there was another one that was supposed to do 10 amps, and they said that it gets pretty warm, doing 10 amps. So I don't know what this one will do, but pretty cheap, cost-effective entertainment. I'll play around with it. If it works, great. If not, I haven't spent a lot of money on it. So anyway, so that is all I had.
Very cool. All right. Next in queue, we have John and Harold and Open Mic. John, what you got tonight? Good to see you.
Yeah, it's been a while. So a couple things. I've been doing designing a new case for my URC smartwatch thing. This one looks a lot more like an actual watch that you might want to actually wear on your wrist. So it takes a much smaller battery, but it also, I've been doing some work on making these go into deep sleep when the screensaver comes on. So I'm working on that. But the main thing that I have is a robot. You guys all remember from last year, this 2-wheel balancing robot that I built that never worked. Couldn't get it to balance, saved my life. So a month or two ago, I saw this website, a link to a website, and I'll share my screen here. And this guy. So this is a very small two-wheel balancing robot. And it's all open source hardware and software. It's very, very small. It has a couple servos inside, so it can actually lift vertically. As it rolls around, it's got brushless motors with magnet encoders, and it's running simple FOC. It's got an ESP32 on it, and you can, normal way to control it is it produces a Wi-Fi access point, and you can just connect your phone to it and bring up a browser on its IP address, and it comes up with a user interface that you can use with a little joystick and whatever. So, and they've got like a full GitHub repo with everything, the hardware, the source, the schematics, the whole 9 yards, including full CAD model of the thing as well, which is kind of cool. So let me stop presenting here. So I bought this. Of course, I have no interest in running it around with my phone in RC mode. So I built a head for it. And so basically everything you see in white above the top is, and above that is all stuff that I designed. It's basically a mount that goes on the existing screw heads. And there's a servo, a very, very small servo that will give me a certain amount of tilt on the head. And so on the back here, there's basically 5 circuit boards, and they're edge soldered together to make it so I don't have to connect them. And so it has one of these little Palalu 5-volt 5-amp regulators, and it has a WaveShare ESP32S3, which is, I bought a few of them off of Amazon, little tiny board. It's literally ESP32S3. It's got 2 meg of PS RAM and 4 meg of flash, and it's a full-blown ESP32 with a USB-C connector. So I'm running MicroPython on that. I've got a BNO 085 9-axis IMU on the top, which I'm not using for balancing. I'm just using it for basically yaw. And I've got a couple LiDAR sensors on the side. These are the VL53L1X LiDAR sensors that I bought from Ali. They're basically this little tiny guy. They're like $5 or $8 or something on Ali. And then on the front is the real trick. This is the same camera board that I was going to put on my balancing bot. It's the OpenMV, well, the Arduino Nicola Vision camera. It's an OpenMV board, and so it's got a 32-bit ARM processor on it, like an STM32750 or something like that. It's a big honking ARM chip. It's got a LiDAR sensor, basically the same as the ones that I have on the side here. It's a slightly different model, but it has more or less the same specs and the same API. So I basically got a LiDAR going out each side, one on the front, and this camera. And of course the camera, you're running OpenMV, which runs under MicroPython, and it implements a pretty decent subset of OpenCV. So you can do, for instance, April tag detection in real time. So it can do that. It can do edge detection and line segmentation, and there's all kinds of stuff. There's different things. You can even load some of the edge model stuff if you want to use it for that. I'm not planning on using for that, but so the idea here is the onboard ESP32 handles balancing and motion. So you can basically tell it, it balances on its own. It's got an MPU 6050. And so it'll balance on its own. You can tell it to move forward. You can tell it to turn. You can tell it to adjust its height, like the servos for that. And you do all this over a WebSockets interface over Wi-Fi. So what I'm going to do, I'm going to take this ESP32S3 and connect to this ESP32, and basically you're sending JSON packets over this WebSocket. So it's going to make decisions about, you know, the autonomous controller that I'm going to write in MicroPython is going to make decisions about where it wants to go, and it will send those motion commands to the onboard ESP32 so that it can roll around. And then it can also read, of course, all of the sensors that I have, the 9-axis IMU, the 3 LiDARs, and the camera. And it can also tilt its head down quite a bit and up a little bit to if it needs to see something more clearly. So the basic idea that I have for this is sort of an indoor exploration robot. I mean, it can't go over big bumps and things like that because it'll fall over. But if you've got a reasonably flat floor, it can roll around, and it will use the camera, and I'll have April tags in various places, and you know, do some kind of mapping and all that jazz. So yeah, that's what I've been working on lately.
Oh, nice.
It's pretty cool. It's looking good.
Yeah, it took a fair amount of time to design the PCB. It's basically a five separate PCBs in one that I'll show you here. Let me share my screen again for a second.
Let me ask you a question, because I've met Fred over here. Is it running yet?
Oh, the robot runs fine. I'm just in the process of bringing everything up. So in the last few days, I've validated that the ESP32S3 can talk to the LiDARs. It can talk to the IMU. I haven't tested. I've been playing with the camera on my PC. I haven't tested. I basically have a UART link between them to talk to it. So I'm still in the process of bringing up this board. I only got it working a few days ago. So yeah, it's I'm pretty happy with it.
But you've run the base with the dish on the top.
Well, I mean, you can run it. I can turn it
Right.
on and run it. That's not an issue.
With the weight added on top.
Yeah. This thing
Okay.
weighs almost nothing, right? It's only a
That's
few
why I was
grams.
curious, was they able to handle the additional weight? And
Oh yeah, I don't think it'll be a problem.
so you've tested that part out already.
Yeah, I haven't actually tested it out, but it's not hard to test. It's a really simple setup. So if somebody else, well,
I think Kareem listed a challenge for you. If you could get your choreography down like, you know, they did for that robot on that video, man, that would be.
if I can get my what?
It looks like it's dancing, you know, it's like pirouetting.
Oh.
And take a look at the video. It's pretty impressive.
I posted a link
Yeah.
to the big brother of that platform.
Right, yeah. There's
Yeah, do the Boston Dynamics dance. Is that what you're referring to?
yeah, I'm not planning on.
It's got its own dance moves. I think.
No. This is legitimately the big brother by the same
Yeah,
maker.
Okay.
And
Oh, is that
it's the ESO2, and it's
Yeah.
nowhere near Boston Dynamics kind of stuff, but
No.
it's a nice, capable, bigger version of that.
Yeah, it's impressive. So what does that thing have on the top in the video? Is that a solar panel or something? Looks like a big flat.
That's actually an LC. No, what is it's a touch screen.
Oh,
And I don't think he's gotten around to implementing it yet, but I think the touch screen is sort of meant to sort of give some information about what load is on and where it is, that kind of stuff.
There it goes.
So this is just rolling around with my phone. and you can adjust the height.
Oh.
And that sort of thing. So it works.
Oh, here we go.
So,
Yeah, they use gimbal motors on those.
Nice high
Yeah.
torque, low speed.
Yeah, they're they work pretty well. I'm happy with it. That's it for me.
That's pretty cool. So what, you have a timeline, or are you just knocking it out as you can? Oh, John.
Sorry, what was that?
Yeah. Do you have a specific timeline and target, or are you just picking away?
No, I'm just picking away at it.
Yeah. It's pretty cool. I was looking at Kareem, the one you found, the Big Brother version, and it's the mechanics with the whatever you call that style of legs was interesting to me.
Yeah.
The double knee kind
Double knee, yeah.
of deal.
Yeah, the mech warrior people call that chicken walkers because they have legs like a chicken, and the way their knees bend backwards and things like that.
But that one is,
The Big Brother is both directions.
yeah. It's got two knees for each leg.
But more like our knees, not chicken knees.
Star Wars.
Didn't Bruton just put out a video with like a cycloidic drive and looking like an AT-AT from Star Wars looking thing?
Didn't see it.
Sorry.
I mean, no, literally it just dropped the last day or so. And if if you're not I'm a YouTube hound, and so I have to go look for it. I put it on my watch later, so because I ain't got time to watch it right now. So
All right. Well, Harold, I think you're next in queue before open mic, or you're the first one open mic.
I am the first one open mic because I don't have a robot thing here. Let me show you. I got a little close-up action. This is a. I'm not so sure that. I ordered this off of AliExpress. I found it for like $5, but it costs like $8 and change to get it shipped here. It's insane. So there's this kit is actually on Amazon for like $25, and I'm not sure after all said and done, you shouldn't just order it from Amazon and be done with it because it's literally the same kit. So what happens is it's a MP3. You get all the business ends here for an MP3 player, that kind of stuff. And also it's a Bluetooth. You wire it up to Bluetooth, so you do a speaker thing. The reason I got it because I thought it was cool. It came with some speakers, and I've got one of those. I got an idea of maybe I can mount the speakers inside one of those micro tool chests that were hot and popular about a year ago. That still are kind of. Lowe's has them. Harbor Freight has them. They're just little bitty tool chests, right? And I figured, maybe I can make my own beatbox, because what it came with all that, which is kind of cool. I saw it on this. There's a cat out there named Hacktuber. Hacktuber, if you ever see that guy, he finds things on AliExpress for like 99 cents, orders one of them up, and then plays with them and tells you if they're any good or not. So he's got some pretty cheap stuff. He finds, look, I got it, and no bubbles. He gets no bubbles in there, so you don't get to pop the bubbles. But anyway, he had this on there, and I was looking at it, and why I got it was because I thought I could just mount this into that thing pretty fast, hack it up a little bit, because on the back side of this thing is 96 surface mount LEDs that do not come mounted. You have to mount them yourself. And I had never done any SMDs at all. In fact, this whole board, you have to mount all the stuff yourself, but I'd never done any of this myself. I started up here, and this looks like, I don't know, some kind of war-torn something or another. I did a terrible job of it. But it turns out my paste was old, because I went and got me some new paste the next day, and I did that on this backside. And if you'll see, it's not the greatest, but it ain't bad.
Okay. Let me, those are LEDs?
Yeah, these are all LEDs. They got
Oh,
red, green, and blue LEDs in rows.
Oh, really? Are they addressable?
No.
Oh.
I say they're not addressable because how this thing works is you pull a sound source off a speaker, you wire it into here.
Okay.
See where it says M for music.
Uh-huh.
And it's got this funky LED here that if you look right there, it looks like it'd be a JTAG, something or another, or a serial port on it, where if you connect it up to it, I bet you could program this thing to do something. But I haven't gotten that far.
And
And
you have I don't mean to keep interrupting you.
no.
Can you post the URL where you got that?
Sure, I'll go look for it and I'll post it up for you there, Mike.
Okay.
Not a problem. It comes with a nice laser cut. Oh, camera down. Wait a minute. Comes with a nice laser cut, bunch of boxes to put it in, on the thing, and it does MP3. And I'll go look it up. I'll drop it in the chat.
Appreciate it. I'm fixing to get into a little bit of LEDs. I'm gonna put on that claw machine I'm making. I want to learn. I don't know anything about addressable LED. RGB LEDs.
Yeah, I say none of these are that. It's just a big old matrix, but it's not saying you couldn't control them somehow. And I just but anyway, I'll put it up there and you do with it what you want.
Yeah, it'll. You know how AliExpress is? They'll put a bunch of stuff on the page.
Yeah, and I will.
It's like a flea market.
I will put. The problem with AliExpress is that when I got this, I was expecting this and I was glad I got it, but there may be a different version of this you'll get that just has 6 or 8 LEDs that kind of light up here, not the whole thing. So got to be careful. The one on Amazon, I'll find them both for you. The one on Amazon, you're saying this is the one you're going to get. And AliExpress, as much as I like them because they're cheap, I hate them. Anybody want some boats? So I ordered these. I didn't order these. I ordered Misi Mouses because I like the Bamboo Labs for $2.60. I like the Bamboo Labs mice innards because I print my own Misi mouse thing. And it's not the greatest mouse, but it does what I want it to do, especially for $2.60 in class. And when I showed up, I got boats. And I argued with the guy, with the person on the other end. So, and you ordered boats. I said, no, I didn't. Look, see where I'm underlining? This is what I ordered. And if you look at the thing, the picture shows boats. The picture in his ad shows boats and shows mouse. And if you look at what's in my cart, it says boat in little tiny letters, but in the big description, it says mouse. It says the mouse thing. So who knows? He goes, okay, I'll give you back half. I'm like, cool. I spent 20 minutes dealing with this and it cost me $2 and I got $2.60 out of it. I think I lost. I know I lost. So, but anyway, that's me whining, like I never whine. So, anywho, that's about all I got on the whole deal. And I'll go look for the links there, Mike.
And another online sales story.
Yeah.
So I got boats. Anybody wants one of those boats? It comes with a little wind-up motor, and you print like a benchy looking kind of thing, and you put the motor on the back of the benchy, and it motorboats around a little bit. I'll just give it to you next time I see you.
Whoever wants a boat.
Whoever wants a boat can have it.
Yeah, I think with AliExpress, expect the worst and be surprised if you get anything,
Yeah.
Expect you'll get nothing. And when something shows up, you're like, wow, it showed up.
Carl, I got something I might want to share.
What you got? Let's
Well,
see.
I'm a crappie fisherman. That's another one of my hobbies. And we use, anybody ever heard of LiveScope? We use that. It's an underwater sonar. It's modern sonar. The old depth finders were you would drift over a part of the lake and it would take picture slices of the, and what you were seeing on your sonar screen, you were seeing history. You were seeing what you did like that. Well, there's a new sonar, and it's not new. It might be close to 10 years old now, but it's called LiveScope, and it takes you're seeing real-time images underwater with it. I was wanting to show you. This is off my boat, off of my depth finder, and I just got to thinking about it. You know, we deal with sensors and time and flight sensors, and this I thought, well, maybe this has some kind of form of LiDAR, but it's not. I used AI and I checked it out, and it says it's just I'm fixing to show it to you. It's just an advanced sonar, and I'll show you a picture of it, and then I'll explain it to you while I'm showing it to you. I'm going to present.
Is that the one that can identify the fish species for you?
The what?
The species of fish?
Yeah, well, I can show it to you. There it is. All right. I'm going to allow this.
My nephew made an argument when he was like 16 that his dad really needed to get the. I think it might have been this one.
Is it? Do y'all see it?
Yeah.
You see it over here in my mouse and all that?
Yeah.
My cursor. All right. This is a picture. This right here. Now crappie. I don't know if y'all know that crappie. Like this is in the middle of summer fishing. I don't fish in the spring, to where everybody's in the creek fishing. I fish crappie out in the middle of the lake, and you use this. This is. Do you see my mouse cursor moving?
Yeah.
Okay. This is the bottom of the lake right here. All right. This right here is structure. Like somebody might, it might be a dead tree, or somebody might drop me. I have over the years have put together these PVC structures and sank them, and crappie love to live on those things. So anyway, I'm fixing to turn it on. I'll explain it to you. The top over here where my cursor is, that's where the transducer is sticking in the water at the top on my boat. And this area where it's an angle, that angle line, that's the back of the transducer, and this is the transducer shooting out in front of my boat. So this part of the brush is right under my transducer, and I'm sitting right there. Okay, you can even see your hook. I'm fixing to turn it on, and you'll see things start moving, and like this right here where my cursor is, that's actually a fish.
Huh.
And you'll see it start moving when I turn it on. You see how it's moving around, that one right there?
Oh, yeah.
And you can see them, and I can kind of show you what I probably tell you what's fish. And I'll pause it right now. These are all fish.
All the little black, the dark areas.
The white areas, the ones that brighten up, are all fish. Now this right here is like a limb, and there's a limb, and there's a limb. But if you see something that looks like a little fine saucer or whatever, that's a fish most of the time.
All right.
And you can drop your hook down. I don't see mine in there right now because I'm videoing my depth finder. But I was wondering, I thought that technology was wild, how that works. And it's something, because it's real time. And when you drop a hook, everybody used to think it's cheating, but nowadays that's just how it's done.
Yeah.
That's just how it's done.
These fish don't have a chance.
They don't have a chance. Well, here's the thing. Here's the key about that. You can see the fish there, but you can't make them eat. They might have already eaten. And so so how a guy like me fishes is you'll go to one of these underwater structures, and he might catch one or two off of here, and the rest of them won't bite. And you got these spots marked with GPS all over in different places in the lake. And that's how you do it. You might hang, if they ain't biting here, you don't hang around here and take a nap. You go to the other place. And so that's how we catch. And I'm not saying, I'm not bragging, and because I'm pretty normal fisher, but it's because of the electronics I have. I always catch fish, always. And it's not me, it's the electronics. So I always come home about 8 or so, you know. So anyway, I thought I'd share that since it has something to do with you know, time of flight or whatever, sonar, or a lot of sensors we use in our hobby. And I'm not sure how come we can't kind of, because let me show you how that's grafted off. You've got the depth of the lake right here. You see the numbers on the side?
Yeah.
That's 16 foot. That's what I'm fishing. This right here is horizontally going that way is right there is zero. And in 2 foot, 0. 2 foot, 4 foot, 6 foot, 8 foot. So I know that if that's right here, that's 8 foot away from where I'm sitting. That's pretty good. So anyway, is that what you were talking about? It was your nephew that was talking about
somebody's voice.
Huh?
I got a bad network. I heard breakup or somewhere, but
You can't hear me?
now I can. That's funny.
Well, anyway, that's all I wanted to show you. And it'd be kind of neat when we get, I don't know, I guess it won't be worth having our hobby if it gets that good. But I don't know, that device, huh?
You should see the comments that Kareem put in, something about teach a man to sonar. And,
right.
And you know, that takes all the fun out of it. Just switch to dynamite.
No, it doesn't really. No, because it doesn't. It doesn't take fun out of it. I have a blast. So
Well,
it's a heck
dynamite
of a
would give you
lot.
a
Let me
bigger
tell you,
blast.
it's a heck of a lot more fun to catch a fish than to not catch a fish. I mean, big difference. So anyway, that's it.
Especially if you're out there all day.
Did you say your nephew was talking about something like this, Carl?
Yeah, I think he is 16, and he was trying to convince his dad why he needed one. He absolutely needed one for his birthday. It was a mandatory must-have kind of a thing. There's a family investment, you see.
Well, that sonar, that's not counting the display.
right.
The sonar itself with its amplifier is $1,500
Yeah.
just for the transducer and the amplifier.
Yeah.
And then you
I
got to
just
buy the depth finder.
I just logged in. Where's the fish? I'm trying to figure it
Oh,
out.
let me restart it and I'll show it to you.
Oh, I'll just zoom through it. Yeah.
These fish are 8-inch or how?
10, you got 10. I don't know how big these fish are, but
Yeah.
if you see one and catch it, you can kind of, I kind of gauge. There they are moving right there. See my cursor?
Movement. Yeah. Okay.
Yeah, that movement, that's all fish.
Hmm.
Now you can't keep, it's against the law to keep a crappie under 10 inch. So,
Oh, okay.
but when I drop, I fish with minnows, and I could kind of judge how big my minnow is down there. You know, it contrast to the scale it to whatever it's sitting by. So anyway, I thought that was, I mean, I don't know how to do that. That is just amazing. So
It's quite nice imaging.
anyway, that's it.
Keeps you dinner. Well, thanks. That's pretty cool. I hadn't seen one working before.
Well, now you know that is it your brother?
Nephew, yeah. My sister's son.
Yeah, but your sisters. Well, they need to get one. Just tell them I said so.
Yeah, I think they did, but I'll tell them it has Michael's stamp of approval. They're in good company.
You can make a lot of trips to the HEB fish market, you know.
That's what I'm thinking. A red lobster.
You know, my brother told me.
For you.
My brother told me I sure spend a lot of money for free fish.
Yeah.
Of course, that doesn't include the $30,000 bass boat that you got to stick.
No, I got a $750 Craigslist bass boat. So,
Oh, okay.
A step up from an inflatable.
no,
Yeah.
well, it's a step up from a John boat,
Okay.
but it's fun, man. It ain't about the money anyway. Not having fun.
So speaking of spending money, I don't know if you saw this article, but I'll show it to you. I thought it was interesting. So let's see. So there's seemingly a robot you can get for only measly $6,000.
So 3 sonars.
So yeah, see, this could jump in the water. Well, no, I don't think it could jump in the water to get the fish, but
Evaluated as to how many sonars you could buy.
Michael got a bargain.
it seems it can do a lot of movement. It may even be able to do the housework. Oh, somewhere
I was gonna say, if you could do that, 6,000, man, that's might be worth it.
Does it do
That's fine.
stairs?
Well, somewhere in there's a video of it. There we are. Okay.
Handstands on a cliff.
Do handstands. Like
That's why it's amazing.
That's its one move. That's its one move, all right.
how tall is that thing? Yeah, pretty tall.
Okay, I gotta know if you get 20 seconds of movement out of it and you're gonna start the battery. Is that how that works?
Probably.
Let's see. Does it tell you that?
Battery that runs for like 20 minutes costs another 6,000. Yeah.
Maybe it's nuclear powered.
Oh yeah, just a fusion.
That's the guy with motion capture sensors fed into Blender. Looks a little too natural.
It does look awful skinny.
Yeah.
All those motors
So,
and wires and stuff and all those kinds of things you think you'd need for that.
so do they tell you how long it can run? Yes.
Wow. Silicon animatronic face.
How long of an extension cord do you have?
Yeah.
And it doesn't say. Because the 25-kilogram robot combines
Yeah, that's pretty heavy. That's like 50 pounds.
26 degree of freedoms.
Batteries are real heavy though.
Custom develop.
Somehow it looks a little too good to be true.
Wonder
So,
if that's subsidized cost.
but I thought that was interesting. And then speaking of batteries and the robot, I have this other one to show you then. So let me switch this. Okay, and share screen. I think this. Yeah. So there's this one. Speaking of batteries, so what this one does, it basically change out its batteries.
Yeah.
So you can see this is bulk is this battery, but
Pretty good sized battery.
I think they mounted it just to make it look awkward.
well, yes. Yeah.
Like it can
The
do it.
robot, the front and the back is the same. So at least in my mind. So yeah. But it's about the same size as the other one. So I'm thinking, yeah.
They should make it, when it gets a new battery, make its eyes bug out or something, like it. Oh.
So yeah.
I found a page with
That
all the
one is
specs.
5 feet 3 inches. It's 95 pounds. It has 20 joints,
Wow.
and it uses 48-volt battery.
But can it slice bread and make toast?
And it seems it can go for 2 hours on walking on that battery pack.
I found a page with the specs on that Unitree robot. Want me to show it?
Yeah. So let me stop this. Okay.
Let's see.
Oh, Copilot said the video is a PSA about deep fake videos. Nice.
Do you see the screen?
Yep.
Yeah.
Okay. Yeah, so this says battery's 2 hours. Looks like it's under the armpit.
So yeah, similar to the other one then.
Yeah, so it's like 35 kilograms, which is 70 pounds, and 130 centimeters, which is about 4 feet
This
high.
was a
Yeah.
little smaller than the other one, but not much.
Yeah. So
Yeah, it'd need a bigger butt to pull one out of its backside. So
yeah, so that's just some of the high level specs for it. Has a depth camera and a LiDAR. Hey.
Well,
Let's
so
see
it'll be interesting
Can't-
if they really do sell it at that price. Because I thought that's starting to get to a price that's might be useful.
So I guess the other one can do handstands and running, but
Well, I think this one can do it too.
probably.
When they both can. I mean, they both look very much the same if you notice. The only difference is the battery's in the back on the one, the other one's on the side.
2 meters per second.
That's pretty fast. Yeah. So that's pretty. Yeah, you can do a lot with it. 5-watt speaker, so it can't really yell.
I don't know. 5 watts can be pretty loud.
Okay. Yeah. All right, I'm gonna stop.
Cool. Well, I did something kind of fun last week I forgot to mention. I think it could make for an interesting club outing, but I wonder, has anyone here done a tour of the Amazon fulfillment, Amazon warehouse, like in Grapevine?
Nope.
No.
So it turns out they offer these for free to the public. They do a morning session and an afternoon session, I think now 4 days a week out in Grapevine. So we did the morning session last week, work colleagues and I, and it's pretty interesting.
So did the robot run over you all or try to repackage you?
No, but they had, I don't have an easy way to share the video that I took, but they showed the process from the intake docks where the parts they sell, the stuff they sell comes in. And they showed how that gets deboxed and put on the mobile racks or bins, and how the robots then dynamically lift the bins and roll them around however they lift them. They showed how when a human has to go in, because the robots flub up every now and then, all these racks that are normally moving around pretty speedily, all of a sudden they just kind of slow down and go while the human's in there walking around with their little "don't run over me" backpack light on. And then the moment the human walks out, they're all behind, so they speed up really fast, and then they catch up to normal. And then they show how the humans have they got these stations where of course the robots bring the inventory to the station, the pick station, and it shines a light on the bin where the part is, because there's 6 or 10 high bins, and so it says get this item. It shows a photo from that bin, and then it has a 5 wide another set of totes, and the light lights up on it. So the human has, like, as soon as it says get this part, a timer starts. 1, 2, 3. So they reach over and grab the thing and then put it in they scan it and they put it in the right thing and hit the go button, and then it says, okay, now get this part. So it's like if the human is slow, does it have a cattle prod? Does it have like a cattle prod and pokes the human? Say, hey, get faster. You know, there was we went in as we stood and waited around it at the start, thinking about what an awful place it must be, and how as much as you like to have packages delivered, what kind of painful process is it to work in that environment when you're graded on everything? But they did a good job of picking tour guides, because they put a really positive foot forward, and you know, you could even see that as you walked around, they did things to take care. I mean, to my view, it's a highly repetitive, really boring task, but you could see that they built things into the workflow to try and help people deal with it. So like that, like little things. There was each of these workstations had their own fridge, so you could put your lunch and your drinks. Every so often, after it's timing you on how long you're doing, it would say, okay, you got to take an enforced break now, so no parts would come to you, and it would put the thing up on there so you could do different stretches and move around, and so it was pretty impressive. But the wild part was, like, at the very end, after all is said and done, they had this conveyor belt that runs kind of like the length of the building. And the conveyor belt was running at 15 miles an hour. And it had these little chutes that kind of like angled off to the side. So at the one end, all the parts after they'd been picked and boxed, and then this extra scanner at the end would flash and it'd get on this 15 mile an hour thing. So these packages are racing by. And as they're racing by the conveyor belt has these arms. So it's like, let's say it's going this way, right? And these little arms that go along with it, when it starts to approach the right chute, the arms would like gradually push it over and knock it into the chute at just the right time. 15 miles an hour. It's pretty wild. And then I noticed that, there's a lot of these conveyor belts that are angled up and down and all around, and my shoulder's awfully close to this one. And what's that little red cord? Oh, that's the emergency stop. So they take you close enough that you could probably cause a problem by grabbing the emergency stop. But that would wreck it, so we didn't do that.
Yep. No more Amazon tours for you then, I think.
You mentioned conveyor belts, Carl.
Yeah.
I've been hanging some of the 3D modeler stuff. And there's one that's pretty popular by the name of K2 Kevin. He makes the rugged series of things. And if you've done very many 3D printing and that kind of stuff, you've probably seen some of his work. He has a bunch of bamboo printers, H2Ds, X1Cs, that kind of stuff. And if you do multi material printing, you know what printer poop is. It's the purge out of the hot end to do all the stuff. Well, the problem is when you got that many printers going on, he doesn't have a print farm, but he has a number of them going, and so that stuff builds up over time. And so he made his own solution. So what he did, he's got 3 of them set up against the back wall. He 3D printed a bunch of conveyor belts and make it so that when it comes out the print chute, it hits the conveyor belt. Then every so often, every so many minutes, he runs them all for about a minute, and it goes down, drops down. There's the next printer, drops down. There's the next printer, and then in the trash bucket. he runs them as long as his friends are running. He goes, I wonder if I could do something special. I said, yeah, you should probably put a camera on that thing and detect it. You don't care what's on the belt, but if something's on the belt, run the thing, you know, and that kind of stuff. And he goes, oh, that might be fun and stuff. Anyway, I didn't mean to take over your story, Carl, but the conveyor belt thing, and I'm like, hey, that flash. And he was demonstrating it by putting some ducks, and you can see the ducks go in his background.
Ducks across the way.
Yeah.
To the robot septic tank.
Exactly.
I was reading something that said that Wemo's coming to Dallas
next year. Yeah.
Yeah. And so they're saying that if all the cars were self-driving, robotic, traffic could be a lot faster. Sort of like that conveyor belt that Carl's talking about.
Yeah. Yeah. Well, theory.
One of these days, it's going to be like that.
Yeah, well, some of the theory, you can see it happening right now. So you had a red light. You got 10 cars in front of you, right? The red light turns green. How long is it before you actually get to go? A long time, right? You're sitting there waiting to go. But if a computer, because you don't know that the person in front of you is aware enough to actually hit the go button, right? So you have to wait till you get distance to go. So you have to wait 10 times that distance before you can go. If everybody's driving robotic cars and they're all robotic cars, you hit the green button, all 10 of them go at the same time because they're talking to one another. They know what they're going to do.
But if there's only one human in a car driving it, it'll be like
You got to slow down.
all of them slow down.
Totally screwed up.
It's like, well, Carl's driving again, so we got to go slow again. So
Gotta go slow. So
Damn, a damn human.
So just a dumb question. Just those online, would anybody be interested if like as a club outing, we tried to arrange that sometime? It'd have to be a weekday. And I did ask about group things, and they said they get schools and stuff going now and then, but I don't know how to arrange it, but I could talk to Paul about it.
Yeah.
Arrange to do what?
Well, for
Visit
DPRG
Amazon.
to go as a group on the Amazon tour, then go out to lunch or something.
Yeah. I'd be game for that. Of course, I'm retired, so
Yeah.
so I can go anytime.
All right. I'll bring it up with Paul.
Yeah, let us know how it goes.
I'm guessing that because my colleague had a really hard time getting in, and they called me at like 8 at night and said, "Do you want to do this tomorrow?"
Yeah.
Okay.
And they had someone drop out. Huh?
I said yes, and 5 minutes later they got tickets. So apparently they go quickly or can. So I don't know how you get 10 spots at once or 20, but
Wow. Yeah.
it starts with wanting to do it. It might have to be planned in the future, but it's a good tour.
Or tomorrow.
Yeah, not tomorrow. And they had, because it's a loud place. It is I watched my watch. Is typically 80 decibels to 90, somewhere in there. Rarely over 88, but it was in that range. So how do you listen to the tour guide? Well, they set you up with sound killing earmuffs that had a boom mic. So we were all connected on the radio. And I mean, the tour guide was 30 feet ahead, and you could all still talk. It was a good deal.
Yeah, I'd sure be interested.
Rainbow that never died.
Hey, good. I'll
She call it Tupperware plexiglass tree.
Yeah.
These are back in the 70s.
Well, open mic keeps going on. Do we have any other?
Yeah, you talk about, automated traffic and stuff like that. There's, I think in the UK, the pedestrian buttons that are at intersections to, hopefully let you
The ones
pass.
that never work.
Apparently they said a lot of those are disabled now. So you can stand there and press the button all day. It doesn't really do anything.
I never used it. Never worked.
Even
What's
if it
that?
beeps? Like you press a button and it beeps, it still doesn't do anything?
Apparently not, no. So they, it interfered with the flow of traffic too much to have, cater to the pedestrians. It still would go through its normal timing cycle and allow them to pass, but it wasn't like you could, as a pedestrian, change how the intersection worked. Basically, it was you had to go when it let you go. So, yeah.
So you're
Wonder how
telling
that
me,
worked. Waymo
so you're
or-
telling me, Ray, you're like you did like I did when I was a little kid, got on the elevator and pressed all the buttons, and so you're going over to England now and pressing all the buttons and running around between all four of them to mess with
hitting the traffic buttons. Yeah.
When you go in the elevator, do you have to walk on the left side or the right side? I mean,
I don't know. Didn't
The wrong
really
side.
go any.
And if you did it in Australia, would it be the other side than the left or right? Never mind.
It seems
Yeah,
like it must
could be.
Oh, upside down on the ceiling.
Yeah, upside down.
Yeah, I was wondering in Australia when they draw the maps, is the South Pole on the top?
So,
Good
right.
question. You mean, yeah.
All right.
All right. Well, it sounds pretty good then. So if there's nothing else, why don't we call it a night? I'm putting notes in here as a reminder that we can turn this into an outing at some point. And good.
so did you see like a pile of, robots that needed repairing or that were junk, that
We could throw some of them away for them, right? We could just,
dispose of them for them.
Yeah, spare parts.
Yeah.
Well, it's like a mile long tour, and you go up a couple flights of stairs to get to the second floor, and they only toured you part of the building. So, but we didn't see it wasn't highly technical, right? They didn't have that kind of person on the tour, but she still was, after 5 years working there, was pretty well versed in what they would do. And
So was this in an air conditioned environment? Or was it just an open factory, huge factory?
yeah.
Oh, okay.
It was toasty. It was toasty. They were working on the air conditioning in there, but it wasn't full bore Texas sun, but it wasn't a hospital Arctic zone either. So it was probably 80, 82, I would guess.
Okay.
78, 82, but not, I mean, the humidity was controlled. And I think they said, what'd she say? Something like, I want to say it was 175,000 square feet. And they have maybe 1,000 people work there across all the shifts. And on a really busy day, they might ship 1 million packages.
Wow.
Out of that one FTW6 facility there in Grapevine. Which is right across, as you're on 121 to or from the airport, it's on the south side opposite of Grapevine Mills. So next time you drive by there, if you see a building with the Amazon smile, that's approximately where it is.
Yeah. My wife has an arrangement with this woman at the SPCA. She does meals for the homeless. And so we go to Campbell Soup in Paris, Texas, and get, like pop-top cans of SpaghettiOs and soup really cheap, like 10 cents a can. And so she'll give her the Campbell stuff, and she'll give us dog and cat food. And Amazon apparently donates a bunch of stuff to the SPCA. So she has like a wall of boxes that are Amazon returns, and they can't sell them, we can't sell them, but we can give them away to clients and stuff. So
yeah,
a lot of cases we'll just let them paw through it, but the amount of returns that just the SPCA gets it's phenomenal. It's it just keeps coming. So I did they have an Amazon return pile that
well, they didn't show us that part, but there was this concept they have of they call it Amnesty, and it's part of where I actually respect the management that I saw there, because it means a bunch of different things. So, but the basic thing is that, like, when stuff goes wrong, It's not that you're there to place the blame. It's there to figure out what went wrong so you can fix the process so it doesn't happen again. Because they measure frickin' everything, every little micro step. And so like they have every pick station, they have a little amnesty box because this, I mean, stuff gets dropped. Sometimes the bin it has the wrong part. It says it have this bin, but it has a part, but it has a different part. So whenever that happens, you walk around, you find package on the floor, doesn't go there. You pick it up and put it in the amnesty box, and then they try and figure out where it came from and what they can do to keep it from mixing up again.
Yeah. Huh. Yeah.
It's the robots, because it was really weird to see this person look like the Borg walk around with this backpack on, or like the laser rifle, the games where you have laser shooting, laser guns, laser tag.
Yeah.
So they're the people walking around with these exovests like that, and then they have the word amnesty or something on it. So it's there was a lot of Borg-like aspects because there was an overwhelming burden of acronyms everywhere, and color-coded vests for who does this role and that role, and it's like.
I wonder if for, a bathroom break, a little platform rolls up with a toilet on it, and it's like, you don't have to
there are windows of time, but and if you need to step away, apparently you just tell your manager, I got to tag out for a moment, and then the manager mashes some buttons, and the robots don't come to bug you. They send the inventory somewhere else, and it still happens.
I knew 3 maintenance people.
I mean,
I knew 3 that I worked with.
Yeah,
that came from Amazon, and they didn't like it.
They didn't.
No, they quit there. I don't remember why. They didn't
work.
like it. I forgot why. I'm not going to say they overworked them or.
Every culture and environment is not for everybody. All I can say is that we had a really positive tour guide, and it gave a nice light.
Yeah, I'm not bashing it or nothing. I just can't remember why they quit. But actually, those 3 guys quit where I worked. So they came in at different times. I worked in maintenance department at this plant for over in Grand Prairie for 20 years.
Did you run them off?
Well, they finally ran me off. That's for sure. No, it was just, I don't know. People are just, I don't know what they are today. A lot of people just don't like to work anymore. They just don't, man. And a lot of these younger guys, they'll learn and either work or don't eat because, but they do a lot of job hopping nowadays in manufacturing, at least in maintenance.
I bet. Yeah. All right, guys.
Night.
Night.
Thanks, y'all. Take care now. See you next time.